going to review and extend on the word problems we worked on yesterday. The handout here is not in your equations booklet. So if you are in class with a sub, then I have photocopied it for you. But if you are at home in isolation, you're going to have to print these off, and I have attached them to D2L. So these are some notes that kind of go a little bit deeper into solving different types of problems. So I'm just going to jump right into the first question here, and we're going to use the general steps that it says up here. So it says twice a number is 4 more than 3 times that number. What is the number? And this is very similar to the kind of question we did yesterday. So the first thing we're going to do, it says up here, is declare a variable, like let x equal something. So we're just going to let n equal the number. Step 2, extract information from the word problem and write an expression for each piece of information that is found. So twice a number would be 2n, and 4 more than 3 times that number would be 3n plus 4. Look for 2 expressions that are equivalent. Look for words like same, equivalent, is. And we do have an is right here. So then we're going to set them equal to each other because this is equal to that. And then we're going to solve. So we will solve this. And I'm looking at negative n is equal to 4, which is not quite done. N is equal to negative 4. So we did that. Check that you actually answered the question. Did I find the number? I did. Write a statement that answers the question. So the number is negative 4. And if this was a written response question, I would expect you to write this, and I would expect you to write this, and you would not get full marks without it. Declare the variable, write a conclusion. Very important. So the next question says, 1 more than 3 times a number is 4 less than 5 times a number. If you're watching at home, I would really encourage you to pause the video and see if you can do this one on your own. Let n equal the number. So 1 more than 3 times a number. So 1 more than 3 times a number is 4 less than 5 times that number. So we're going to take 5 times that number and minus 4. What is the number? Let's solve. So I will delete one of these copies of n and end up with 1 equals negative 3n minus 4. Positive 2n, not negative 3n. That's not right. Positive 2n minus 4. Then we'll add 4 to both sides. And we have 5, which is 2n. Now, at first I wondered if I did something wrong because it's a fraction, but it doesn't say that it has to be an integer, so I think I'm okay. So the number is 5 over 2. And just leave it in improper form. It doesn't reduce, but if it did, you'd be expected to reduce it. This one gets a little trickier. 2 positive consecutive numbers have a sum of 139. So recall how we're going to list this out. We're going to let x equal the first number. And when it says consecutive, it means one after the other. So the second number is going to be x plus 1. So if the first number happened to be 10, then the second number would be 11. And if you know that trick, then you can set this up. So they have a sum. So we're going to take that, and then we're going to take that. This plus this has a sum of 139. What are the numbers? So then we go into solving. Combine like terms. 2x plus 1 is 139. And 2x is equal to 138. We'll divide both sides by 2. 138 divided by 2 is 69. So x is 69. And the number is 69. And you can check this just to see if the first number is, actually, I did not answer the question. They asked me for both the numbers. So I have to list that the numbers are 6 69 is the first one because that's x. And then 69 plus 1 would be 70, which is the second one. So you can add those together and see that indeed they do make 139. Number 4. The length of a garden is 6 meters less than twice its width. The entire perimeter is 105. So I always draw a rectangle here because I get confused. The length is 6 meters less than twice the width. So I think that I'm just going to let W equal the width. So the width is the shorter side, and it says that this is 6 meters less than twice the width. So 2W minus 6, and this is also 2W minus 6. We also know that the perimeter of the garden is 105. So if we add all of these together, we should get 105. So 105 is going to be 2 of these plus 2 of those. So 2 widths plus 2 lengths. And then you can solve that. Let's see what we end up with. 105 is equal to 2W plus 4W minus 12. And we can combine our like terms. 6W minus 12, add 12 to both sides. And I have 117 is equal to 6. And I'll divide by 6 to get the width. Now, normally I would say please leave it as a fraction. And as a matter of fact, I don't think that reduces. But when you're dealing with lengths and widths, it does make sense to use a decimal. So it's okay to use a decimal in this case. So we found out that W is 19.5, but it asked us to find the garden's dimensions. That means like both of them. So although I have found that this was 19.5, I have not figured out the length. So to get the length, I actually have to evaluate one more time and see what I get. And I'm getting 33. So then you would say that the dimensions are 19.5 meters by 33 meters. So to make sure that you actually answered the question. Question 5. Lisa is 16 years younger than Kathy. If the sum of their ages is 30, how old is Lisa? So which one should we set the variable to? And the answer is, in the end, it shouldn't matter, but sometimes one way is easier than the other. By default, usually students will set L to be Lisa's age instead of K to be Kathy's age, just because that's what you're trying to find in the end. So let's see how this works out for us. So if Lisa is 16 years younger than Kathy, that means Kathy has to be older. So if you take Lisa and you add 16 years, then you're going to get Kathy's age. And then the sum of their ages is 30. So we're going to use this clue to set up our equation. The key word here is. The moment you see is, you're like, ah, that's my key to setting up the equal sign. So I'm going to add Lisa's age, L. I'm going to add that to Kathy's age, L plus 16. And that should come out to 30 because of this is 30. That's easy to understand, but it's hard to come up with on your own unless you've done a little bit of practice on how to set these up. So 2L is equal to 20. So then L must be 10. So Lisa's age is 10. The second page gets much more complicated. These, we have the nickel and dime problems. We have these multi-year problems, the money problems. These are just going to be a little bit more complex. So Dave has a total of 450 in dimes and nickels. He has twice as many dimes as nickels. How many of each coin does he have? So first we're going to choose a variable to set this up. Because he has twice as many dimes as nickels, he's actually got more dimes. So if you have n be the number of nickels, then you're going to have 2n be the number of dimes. So we'll have n equal the number of nickels. It's really important that you specify that this is the number of nickels, not the value of the nickels, because that's going to be something different. And 2n is going to be the number of dimes. Now keep in mind that if we're working in dollars, 1 nickel is actually worth only 0.05, and 1 dime is worth 0.10, so 10 cents versus 5 cents. So if you want to know how much money you have in nickels, you would take 5 cents, but then you would multiply it by the number of nickels that you actually have. And then if you wanted to know how much money you had in dimes, you would take 0.10 and multiply it by the number of dimes you have, which we just said here was 2n. So that's how much money we're going to have. That's an expression for it. But we actually know how much money we're going to have. It says it right here. The total is $4.50. So if you solve this equation, you're going to find out what n is. So let's go through and do that. 0.05n plus 0.20n, because if you multiply those together, it's 0.20. And those happen to be like terms, so I'm going to add them. And then the last step would be to divide both sides by 0.25. So 450 divided by 0.25. I am getting that n is actually equal to 18. So what does that mean? We have 18 nickels. So then the dimes must be twice that. So then 36 dimes, right? So 18 nickels and 36 dimes is what we would have as an answer. So one of the traps that students fall into is letting n equal the number of nickels and d equal the number of dimes, because that makes sense in their head. But the problem with that is then you're going to have two variables here, and it will not be possible to come up with a value for something. So you're not going to be able to solve it with two variables. That's why you need to stick to one variable and try and use that one variable to express the other thing. And that's why these types of problems are quite tricky if you haven't practiced them. I'll just erase this so that we can see the next question a little bit clearer. John is now 3 times as old as his brother Sam. In 5 years, John will be twice as old as Sam will be then. Shouldn't say them, it should say then. Right here. These problems, you really have to know the trick to set them up. So the trick is you want to set up a chart to organize all this information, because there's just too much stuff. Like there's John, and then there's Sam, and then there's now, and there's also in 5 years. So there's a lot of information to organize. So right now, John is 3 times as old as his brother Sam. So if I declare a variable, I think the easiest thing is to let x equal Sam, and then John is 3 times that. So I'm going to say x equals Sam's age now. It's really important that you say whose age, not just age, and also when, like now or in 5 years. It is now. In 5 years, John will be twice as old as Sam will be then. Now, before I use this clue, I already know an expression for 5 years from now, because everybody gains 5 years in 5 years. So this is x plus 5, and this is 3x plus 5. And I don't even need the clue in here to tell me that, because I know that everyone ages by 5 years in 5 years. But we have an additional clue. John will be twice as old as Sam will be then. So John's going to be twice as old as Sam here. So if this is Sam in 5 years, then John is going to be 2 times that. And the fact that we're trying to cram 2 different expressions into one box is the key to your equation, because we have a clue about this, which is 2 times x plus 5, but we also know that in 5 years, naturally, John is going to age by 5 years. And this is the key to coming up with our equation, trying to cram 2 expressions into one box. These two are equals. And the moment you have the equal sign, you have an equation and you can solve it. So this is 2x plus 10. I will minus 2x from both sides. So x plus 5 is equal to 10. And x is equal to 5. So I was asked to find their present ages. So I did find Sam's because that's what X was. So Sam is 5. But then John is 3 times that. So John is going to be 50. Don't forget to go back and make sure you answered the question. Number 8. A man is now 6 times as old as his son. In 6 years, the father will be 3 times as old as the son will be then. Find their present ages. So this is very similar to the previous question here. I would encourage you, if you understood the previous question, to pause the video and give it a try. We got to make a chart. So a man is now 6 times as old as his son. So we have the man and we have the son. And we have now and we have in 6 years. So right now, because he's 6 times as old as his son, we'll just let this one be X and this one be 6X. So let X equal the son's age now. And then in 6 years, naturally, they're both going to gain 6 years. But that's not all the information we have. We also know that at that time, in 6 years, the father will be 3 times as old as the son. So we also know that this guy is going to be 3 times as old as the son is then over here. And there's the key to our equation. So we're going to solve that. 3x plus 18, and then minus 3x. 3x plus 6 is 18. So this is 3x is 12. So x has to be 4. So we're looking for their present ages. So we know that the man is 6 times that. So the man is 24 years old, and then the son is going to just be 4, like so. Last example. Mary and Jessica went to the mall. Mary had $30 and Jessica had $39. Mary bought 3 shirts. Maybe it's just easier to organize this in sort of a chart. So Mary had $30 and Jessica had $39. Mary bought 3 shirts, and Jessica bought 4 of the same shirts. But at the end of the, that's not how you spell shirts. Okay. So at the end of the trip, they had the same amount of money remaining in their pocket. So it was the cost of each shirt. So because I'm looking for the cost of each shirt, I'm just going to let X equal the cost of each shirt. Okay. So then you're going to have Mary who had $30. But then because she bought the shirts, 3 of them, you're going to minus 3x. And then Jess had $39, but she bought 4 of them. So she's going to lose some money. But at the end of the day, they had the same amount of money. So that's where your equal sign comes from. So then we just got to solve it. So I'll plus 4x here. And that'll be 7x. 30 minus 7x is 39. So minus 30. And then negative, oh, that's not 7x. It's going to be positive 1x. Positive x. You don't have to write the 1. So then x is going to be 9. So the cost of 1 shirt is $9. So we had a bunch of clues, and in the end, we're just setting things equal to each other so we can get an equation. So the homework is not included in your equations booklet either, but if you haven't finished the homework from yesterday, you should do that first because this homework is a little bit more challenging. I have attached the homework as a separate document, and you can print that off or just use your phone and look at it do it on a separate piece of paper, and the answers should be included with that as well.